So the category that we are trying to create in the market is that of AI for sensitive information. So mostly we sell into very large enterprises. These are highly regulated and federal agencies. And these guys have, of course, a lot of unstructured and structured data. There's a lot of sensitive needles in their haystack, and we use AI to help them find different kinds of sensitive needles. So just to give you some background on the company and the company story, how we got started. So I got my PhD in machine learning and natural language processing from Columbia, and my thesis was about building machines that could go through unstructured data, unstructured as 19th century British literature, and they could extract characters from the novel, but more than that, they could actually analyze the way different characters interacted with one another, the kind of language they use, the way they interact with other characters, and they could infer things about characters and relationships. So what are the roles characters are playing in the story? What are the relationships with other characters? What are the communities like? How does information flow within this community? So at that time, it didn't seem like obvious how we'd end up commercializing this. But around the time in 2014, when I was graduating, the government, who had funded a lot of my research, saw a lot of commercial potential in what we had built. They gave us a grant, and that's how we got started. So far, it's been really fun building the business, and it was unclear how we'll commercialize this, but it's been great to have real customers. We've been profitable since 2017, but really the metric that we are proud of is that we've had 100% pilot to customer conversion rate. So every time people have compared our technology with their status quo method of finding sensitive needles in a haystack, we've shown that we find everything their method finds, but we find more. So just talking about kind of what the problem is. I'm sure many of you would have heard about GDPR and California adopting a similar regulation. All of this falls in the privacy space. But given this, companies could be fined like 4% of their top line. A few years ago, when Aetna tried to acquire Humana, this merger didn't go through, and they had to pay a breakup fee of $1 billion. Right? These are massive, massive fines. And what are companies doing today to mitigate these disasters or these risks? Believe it or not, the status quo method, the most popular method of finding these needles in a haystack, remains to be based on search terms and manual review. A major bank in New York alone, they've hired over 13,000 people since 2012 looking for sensitive needles in this haystack. As you can imagine, this is inefficient. This is expensive. It takes a lot of time, takes a lot of money, but even after that, they're missing information that they want to be finding. So it's still risky. And just to make it, just to give you an example and make it completely clear. So here's an email from Mike to Sarah. It says lunch. I had lunch with John. He liked his Reuben sandwich today. You should get it ASAP, right? This doesn't look sensitive. I mean, first, it'll be interesting if this email hit any search term, but even if it did, to a manual reviewer, there's nothing interesting about this email, unless, of course, you like Reuben sandwich that much. Until until it becomes clear that, hey, out of thousands of Johns at this organization, this John is John Powell, whose role at the organization is that of a note taker to a board member. That means John has access to non-public material information, and his relationship with Mike is that of friends, and Reuben's sandwich is a code word for a stock they're trading on. It takes all of this semantics, all of this context, all of this understanding to really, see that, oh, this is actually sensitive. And this ties right back to kind of where we started from in my thesis, in that we can analyze human communication, we can infer things about roles of people within an organization, their relationship, and that allows us to zoom into or find many different kinds of sensitive information. So just to summarize, what we built is a platform. It ingests all kinds of unstructured information, emails, text messages, and these machines, they understand, given this communication, they understand people, they understand language, they understand roles of people and relationship. And basically, it starts to understand how does information flow within the organization. And given this understanding, we're able to build point applications or products, that can help customers find things like PII, that can help customer find, traces of bad behavior, sexual harassment, fraud. So these are sort of the applications that we've been able to build on top of our platform. So just to give you a sense of the impact this has had. This is a case study. We worked with a large healthcare company. They had about 2 million documents, and they needed to find a few different kinds of sensitive needles in this haystack. And had they used the status quo method, which is very much based on search terms and manual review, it would have taken them about 20 weeks to review all these documents. We later showed them that their search would have missed about 10% of the sensitive information, and it would have costed them about $4 million. With our technology, we were able to find them the things they were looking for in 2 weeks. That's 10x faster. They sampled the things we marked as not sensitive. We don't want to say we're 100% accurate. We might have missed something, but just using their sampling techniques, they weren't able to find any sensitive information we had missed. And we, even after being faster and more accurate, we were able to save them about $3 million on just one matter. But just taking kind of a step back and looking at 10 years or a roadmap, the really hard problem that we're going after is that of going from unstructured to structured data. And the solution for this problem would have to be using unsupervised machine learning methods. To Ben's point, there are a lot of successful data analytics companies. A lot of them plug into structured databases to mine these insights that are obviously extremely useful. But there's a whole world of unstructured data that has a lot of insights but remains unexplored. So our long-term goal is to bring this world of unstructured data to the world of structured data, so that these successful data analytics companies could mine even more insights, even better insights for the companies. And this is not a new idea. If you think about Splunk at a level of abstraction, what they've done is they took all these unstructured machine data, logs, which were really hard to grep for, really hard to search, and they put structure on these unstructured logs, which was super helpful for people trying to find, hey, why is my application running that slow? And they also used unsupervised methods in that, not a traditional unsupervised machine learning technique, but their methodology is unsupervised in that they don't need people to actually go in and label things in the logs before they can mine that structure. So as I mentioned, just the world of unstructured data, there's just so many different types of documents and types of data that there's just no way we can tackle this problem using supervised machine learning. So a lot of the machine learning we use in-house is mostly unsupervised, And that's really the only way to move this world of unstructured data to the world of structured data. So that's one big technical challenge. It's of course a very hard problem, but just to give you a sense of some other technical challenges that are easier, but also still very interesting that we're dappling with at our company. One is being multilingual. So we work with large organizations. These are global. We need to be language agnostic. So all the tools that have been trained on English version of Wall Street Journal or other journalistic text, these are things that we simply cannot recycle. So we try to stay in a very sort of distributional, semantic space. Dealing with short text, it's a totally different, animal compared to longer text. There's very little context, so it's a lot of different techniques we have to, employ when we want to deal with things like instant messages or Slacks or chat rooms that have a lot of people talking about certain things. Interpretable machine learning. So as I mentioned, we're selling to these highly regulated, large enterprises, to their legal, compliance, and privacy departments, especially when it comes to compliance. Whatever we do, however we find the information, it's important that there's an explanation attached to our findings. If we call something sensitive, how and why. And there's a big trade-off between, performance and making machines interpretable. So just bridging that gap is actually a pretty interesting technical challenge. And finally, we're not trying to replace humans. Humans are still part of the story. These are, we're playing with fire. These are extremely sensitive documents, and eventually we need a human to validate that, in fact, these are sensitive and there's a human in the loop. So it's very important, whatever models we use or the way we design, it's important that the feedback is continuously training the machine, making it smarter, so that the machine is gathering this information and getting more accurate and faster over time. So those are some of the technical challenges. This is one thing we're unable to do fast enough. I'm sure a lot of startup founders would agree with this. Is hire, and it's we see ourselves as a core technology company working on some very interesting technical challenges. Would really appreciate if you guys can spread the word. We're looking for a 360 degree. We've grown quite a bit. We've grown like 5 times over the past 6-7 months. So we're growing pretty rapidly in all directions. But given the kinds of technical challenges we're dappling with, we're still looking for a lot of engineers and researchers, mostly who have backgrounds in graphical models and deep learning. So I would really appreciate if you spread the word, and thank you.
Thank you very much. You alluded to this towards the end, but that idea that you sort of playing with fire, right? Because you're looking for super sensitive information, and if you find it, you've done your job. But if you don't find it, then that's a disaster. That's really interesting, considering that AI ultimately is really good at doing sort of 80 or 90% of the job, but like not 100%. So maybe talk about how you work with humans from almost like a workflow perspective.
Yeah, absolutely. And thankfully for us, the bar is not to be 100% accurate. The bar is search terms and 500 humans, right? And as it turns out, that bar is not that hard to beat with AI. So till we can show that we find all the things this process finds, and we find more, that's good enough. We don't need to be 100% accurate. But to your point, the way the human is in the loop is that we take massive amounts of documents, and we would tell our end customers that, hey, out of these 10 million documents, the thing you're looking for is in this set of 50,000 documents. And of course, we're not guaranteeing that all these 50,000 are sensitive, but in fact, even if 10,000 out of those 50,000 end up being sensitive, we've really reduced their labor, right, their work. So that's where the human continuous learning loop comes in. They look at these 50,000 documents and they'll give feedback to the machine that, oh, actually out of these 40,000 are not. So machine will continue to learn, and the next time this happens, it'll return even a more precise result, if that makes sense. Yeah.
Hi, thank you for the presentation. So one of the problems in this area is false positives. By some measure, I've heard that about 90% of these triggers by traditional methods are false positives, and you just claimed about 99.9% accuracy, which is very close to 6 sigma. So how do you convince people that you actually achieve that, given that they spend all this money because they're afraid of one missed real case? So they're willing to spend all this money on these people sifting through 90% of false positives because they're afraid to miss one real case. So if you're 99.9%, how do you convince the compliance officer that it actually is that?
Sure, yeah. And that's the irony, right, of this whole space, that they're spending time and money, but even then they're missing, information. So the way we convince, and that's why, our conversion rate, has been great, is we just run a proof of concept in parallel, right? Their teams do their job on the same set of data, we do our job. And in the end, we show that, hey, we found everything you guys found, but we found more, right? And not just that, search terms would typically catch, like, out of 10 million, they'll hit on 5 million documents. And so now they're going through 5 million documents. We would, catch like 50,000 documents. So that's where the time saving and cost saving comes from. Yes. Yes, yeah.
Hi, very impressive technology, and when you're finding things like insider trading, that's wonderful. Given that you're working with the government and what you showed can be rolled out things like email, how do you think about the technology's use for things, the government wanted to find resistance of some other kind and use it? How do you think about your client, the government or others using your technology to find things that might not be simple business?
Yeah, so our government, we see a great sort of expansion and opportunity in the government, and a lot of it has to do with FOIA requests. So if you submit a request to get information, the government is spending a lot of human labor and money in getting humans to find trade secrets and redact these secrets before these documents go out. So far, the way we've been helping the government, it's not on the sort of counterterrorism application or the agencies that are investigating. So yeah, I guess we'll have to think of that question, think of that problem, once we get there. But so far, all of our
So how they use it.
Yeah, so we're training and certifying them on how to use the technology, and I mean this is obviously I know exactly what this conversation is leading to. We're obviously very conscious about like an ethical implementation of AI just by design, and think a lot about that. But the functionality that we expose to the end users. so far they're fairly limited. So we're selling point applications like the product that will help them find like privilege information or privacy information. Yeah.
Going back here on your right.
Hi, this is pretty impressive results, and I think your first application is a great one because the value prop is so high for finding sensitive data. But I had one question about the applicability of this beyond that first application. I mean, is this essentially, with your unsupervised learning, a better semantic NLP? And are you looking at applications beyond just the sensitive data, just more general NLP applications of your technology?
Yeah. So right now we're mostly focused on helping. So our end buyers are sort of risk managers, all kinds of risk managers within the enterprise who are like perpetually nervous about where the bullet is coming from. I think when we get to a solution for going from unstructured to structured, and once we're able to build that platform, our approach to scaling the business would be to open it up for third parties to make use of that functionality for the kinds of applications they're interested in. We may or may not enter the space of non-sensitive information, but from our perspective, we'd love to take what we have, convert it into a platform and enable third parties to build other kinds of applications. And in terms of the applicability, yeah, absolutely. I think the applicability of these functionalities go far beyond finding just sensitive information.
All right, one last one.
I'm wondering if you're looking into the emerging AI security, like GANs, adversarial attacks, like images, speech recognition that are not mimicking. Are you looking into that technology?
Not right now. I mean, one thing that becomes a related problem that we're looking at is, of course, this data also has voice, and it also has videos, and it also has images. So we certainly use the functionality of converting these things into text, so we can index them, we can infer things about that kind of data, but we're not in the space of like mimicking video right now.
All right, Apoorv, that's all the time we have. Thank you so much.
Yeah,
This was
thanks,
terrific.
Matt.
We enjoyed it. Thank you.
Appreciate it.